Hey guys, welcome to the last video of the week. Now I know you're probably saying yourself, but Mrs. Rose, tonight's Wednesday. Why is tonight the last video of the week? The reason is because tomorrow you're going to spend some time working on USA test prep and also on my e-class. I'd like you to get used to that format for just a little bit. So we'll talk about that tomorrow. But today we're going to talk about graphing exponential functions. And we're going to spend a lot of time in the next couple of weeks talking about parent functions and graphing the functions and transforming the functions. But for right now, I just want to talk about how to graph an exponential function. The easiest way, according to the textbook, is to choose several values of x, positive, negative, and 0, and generate the ordered pairs, and then plot the points and connect them with a smooth curve. So let's take an example for a minute. Let's take a look at graphing ab to the power of x, where a is greater than 0 and b is greater than 1. If you choose several values of x and then generate the order pairs, okay, negative 1, 0, 1, and 2 are usually pretty good. And then you go ahead and substitute those values in. Please remember, this is the part that worries me a lot, that this exponent only applies to the value that's directly in front of it. So exponents first and then multiplied by the coefficient, okay? This is the numeric coefficient. So let's make sure that we understand to raise the base rate to the power and then multiply by the coefficient. Notice that the curve is rising to the right. The reason why the curve is rising to the right is because b is greater than 1. When b is greater than 1, the typical exponential function will rise to the right. All right, take a look at this one. Notice that because the rate is greater than the previous one, look what happens to the curve. It exponentially grows faster, which means it has a steeper curve. Also, because 5 is greater than 1, you have a rising to the right. Also, please notice it does not cross the boundary of y equals 0. That is called an asymptote. An asymptote is something that it will not cross. It is a limit or boundary. We'll learn more about those when we talk about rational functions. You'll use them a lot in calculus in high school. All right, so what about this one? Oh, wait a minute, Mrs. Rose. You said that if the rate was greater than 1, it would rise to the right. What is different about this function? Oh, Mrs. Rose, there's a negative sign out here. Now, I want you to be careful with that negative. Please remember that that negative is take the opposite of. And also, if you remember from last year, a negative symbol with that would reflect over the x-axis, okay? So, take a look. What happened, ladies and gentlemen? We reflected over the x-axis. Very good. You know, anytime you need to pause this and take a look at what's happened and actually make some notes, that might be a good idea. All right, so take a look at this one. Oh, Mrs. Rose, that's a very steep curve. Why is it very steep? Because 6 is definitely greater than 1. Oh, but Mrs. Rose, it's falling from left to right. I wonder why. Oh, yeah. Reflect over the x-axis. How you doing? Have you stopped and taken a look and taken good notes? Gee, I hope so. All right. Go ahead, take your notes, take a good look. Do you see why it's really important to know your basic squares? Oh, Mrs. Rose, this one's totally different. This one's so bizarre. This one has a reflect over the x. But look, 1/4, that's between 0 and 1. Ms. Rose, that doesn't look at, let me look at that other one. Mrs. Rose, this one, when it reflected, did this. Mrs. Rose, this one is going like this. This one's falling from left to right with the reflection. I wonder why. Can you figure it out? It has something to do with this. Well, that must be true. I must have been right on the previous thing because 6/10 is between 0 and 1. And look, this one falls from left to right. So I should have known that this one would also what? Fall from left to right. I wonder why that is. Take a good look at this, and hopefully you remember that this is called a reciprocal power. Okay? Oops, Miss Rose can't even spell today. Now, I know you may have called that a negative exponent, but let's remember about this starred word and talk about it tomorrow. So, huge glossary card here, huge glossary card. Go ahead and use color pencils so that you make sure that you can tell the difference between whether it's going to rise or fall, okay? Whether it's going to fall or rise, okay? Take a good look at it. Ladies and gentlemen, again, this is a great explanation if you want to read and look. This is a great video for graphing, though I will tell you, to be honest with you, it also goes into logarithms, which is a bit more than what we're going to do this year. And this one's just fun. This is a fun applet where you can play with things to notice what happens to the exponentials. All right, guys, toodles. See you in class tomorrow.